All right, we're going to take a look at polynomial functions and try to get used to looking at an equation and trying to match that with a graph, or just getting an idea of what this is going to look like. And so one thing I want you to know first, just a quick review. If I have y equals x, this is going to be a line, right? X to the first. If I have, I'll even put a 1 there. If I have x squared, this is a U-shaped graph, right? X to the third, we have a little something like this. We start at the bottom left and we end in the top right. X to the fourth, we have this little W shape. X to the fifth, we have one more extra hump than x to the third. So we're looking at 4 changes of directions. And then we can keep going. I know they have x to the sixth, x to the eighth here. But the farther that we go, the more changes in direction we're going to have. And so what I want to do is between a through f, which one goes to this graph? Which function is going to fit this graph? Now, one thing to look for, look at our end behavior. So I start from the bottom left and I'm ending in the top right. So that means it has to be a positive odd power. And so I can get rid of anything that's an even power. And it just so happens there's only one that's an odd power. So this is going to be C. So letter C is going to go with this graph. So this is x to the fifth. Now, when I look at this, it doesn't really look as much like an x to the fifth graph, but we also can't see what's going on up here. But one thing we do notice is that I have a y-intercept at positive 2, so we can kind of look at that. I have 2 changes of direction, so we might guess that it'd be an x to the third function, but because there is no x to the third function, then it must be this x to the fifth. Now, if this were reversed, where it started in the top left and worked our way down, then we'd be looking for something that was negative. Now, on the other side, we have this kind of W-shaped graph. So immediately, our mind should look at that and be thinking, oh, this has to be something like x to the fourth. But let's just go through this process and try to figure this out. So first, end behavior. Let's take a look at these arrows. They are ending toward positive infinity. So as x approaches positive infinity, so does y. As x approaches negative infinity, y is also approaching positive infinity. What that does is it can get rid of every single equation that has a negative out in front. So it can't be b, because that negative, x to the sixth. It can't be e for that reason. Next also, look at the y-intercept. So your constant is going to represent your y-intercept. I have a y-intercept of 2. So I'm going to get rid of f because it has a y-intercept of 3, or a constant of 3. So that means it's got to be between a or d. Now I realize we kind of ran into this issue here where it could have been x to the third or it could have been x to the fifth. And so as we start factoring and as we start getting an idea of what our x-intercepts are going to be just by looking at the equation without using our graphing calculator, that'll make things like this very easy. But on an ACT test or on a test, if you get stuck where you're like, man, I don't know, it's got to be one of these two, but I'm just not sure. I think it looks like this, but I'm not 100% sure. I feel like x to the eighth, I'd have a lot of humps in the middle, and you would be right. And so it would be letter D. Now, how would you know that for sure? Well, one thing that you could do is you could start with A, or start with what you think it is, maybe letter D, and graph it in your graphing calculator and take a look to see if it matches. And then just in case, check the other one. So it's not A. X to the eighth would have a lot more humps in it. So good. So the letter D, this function, x to the fourth, it's positive, and behavior's opening up. We have a constant of 2, which is our y-intercept. And we are crossing the x-axis 4 times. We also don't have any double roots showing, and so if we saw it like bounce off the x-axis and come up, then we would assume that is a double root, but that doesn't happen. So because it crosses 4 times, we can then conclude that it's x to the fourth.